So your direct variation is a linear function. In case you didn't get this yesterday, it's a linear function. And it's written as y equals kx. The constant of variation is the k value. And we can solve for k, and we get k equals y over x. So what we want to do with these groups of numbers, you can just put that on my desk. What you want to do with these groups of numbers, your x and your y, is you want to determine if y varies directly with x. And if it does, we want to see the constant of variation and the function rule. So this is what you need to do. We're searching to see, is k a constant? So is k the same for every set of numbers? Now remember, we just said k equals y over x. So in order to find k, all you have to do is divide your y value by your x value. So 2 divided by 1, your constant would be 2. 6 divided by 3, your constant, again, is 2. 8 divided by 4, your constant is 2. So your k value is the same for all 3 sets of ordered pairs. That means this is a direct variation. As x increases, y increases at the same rate. And that rate is your constant at a rate of 2. So it also asks us to list the constant, so we're just going to say that k equals 2. And then when it says to write the function rule, that means what if we wanted to input an x or a y value? Then what we need to do is we need to follow the y equals kx equation. We know what k is, so now to make a function rule for this situation, we just plug in k, and our rule is y equals 2x. So there are 3 parts to that answer there. Yes, it's a direct variation. K equals 2, your constant is 2, and then your function rule is y equals 2x. For part B, determine if it's a direct variation by finding the k value. We have 4 divided by 1 is 4. 8 divided by 2 is 4. 11 divided by 3 is not 4, right? 11 divided by 3 gives you a decimal of 3 2/3, or 3.6. Repeating. So since all of our k values are not the same, this is not a direct variation. And then the got it questions, they're the same thing. You have to find k, and if k is the same, then you know that it varies directly. So what do you guys think for A? Is A a direct variation? Sadie?
Yes.
Yes. What is our k value?
-7.
Exactly. And she found that by taking y divided by x, and every time she got -7. So yes, this is a direct variation. K is -7. And can somebody give me the function rule? Selena.
Y equals -7x.
Very good. Let's see what happens for B. 5 over 2 equals 2.5. 7 over 3 equals 2 1/3. Obviously, those aren't the same numbers, so it doesn't even matter what 13 over 6 equals, because already we know that our k values are different. And as soon as you know your k values are different, this is not a direct variation, because you have different k values. Now you can look at an equation and determine if it's a direct variation simply by looking to see if it's in that form of y equals kx. So in example A, we have 3y equals 7x. What we want to do is we want to solve for y and then just compare it to our y equals kx equation. So divide by 3 on both sides, and y equals 7 over 3x. So is that written in the same form of y equals kx? Yes, y equals a constant times x. So that's how we know, yes, this is a direct variation. And then our k value is just the coefficient on x. It's 7 over 3. For example B, in order to get y by itself, we're going to divide both sides by 7. Remember, both terms on the right side get divided by 7, so we get y equals 2x plus 1. Where at?
How'd you get?
1?
Yeah.
You have to divide the 14x by 7 and 7 by 7. So what do you guys think? Is this in the form y equals kx? Cody? Right. That plus 1 at the end makes a big difference. It's not in the form y equals kx, therefore this is not a direct variation. Got it? Question number 2 is just more of the same. Solve for y first. So in this case, we've got to do 2 steps before we have y by itself. Subtract 5x. 3y equals negative 5x. Divide by 3. Y is negative 5 over 3x. So tell me, is this a direct variation? And what's the k value? Jordan?
Yes, it is, and the k value is -5.
Very good. And B is a little bit of a tricky one. What do you guys think? Morgan?
No, because x is being divided by what would be the k value.
I told you it was tricky. Anybody have a different answer? Ashley?
If you multiply each side by 9, it'd be 9y equals x, so yes.
It is a yes. What's the coefficient on x? 1. So y equals 1x over 9. That's just like having the coefficient as 1/9. It just looks a little bit different. This is still y equals kx, with k being 1/9, and this is a direct variation. So really when you're given an equation, you just want to make sure you have y solved for, and then you can determine whether it's a direct variation or not. Now when you have a direct variation, for all of your ordered pairs, x, y's, you're going to have y1 over x1 equals y2 over x2. So with your ordered pairs, you have x1, y1, x2, y2. Your ratios of y1 to x1 and y2 to x2 are going to be equal because they are a direct variation. So they are going to be equal. They are probably just going to be written a different way. So maybe y1 over x1 is 1/2, whereas y2 over x2 is 4 over 8. They look different, but they're really the same value. And that's going to be true for any time you have a direct variation. So whenever you solve direct variations, you can just use proportions. Suppose y varies directly with x. Y is 9 when x is negative 15. What is y when x is 21? Y is 9 when x is negative 15. What is y when x is 21? So you just set this up as y1 over x1 and y2 over x2. How do we solve proportions? Sadie?
Cross multiply.
Yes, you do. And you get 189 equals negative 15y. And when you divide, it doesn't give you a nice whole number. It gives you y equals negative 12.6. Y is negative 12.6. For number 3, y varies directly with x when y is 15, when x is 3. What is y when x is 12? Sid?
60.
Right. 180 equals 3y. So y is 60.